Let me go to YouTube.
Mason, can we keep your hands to yourself? Come on. Alright, we start factoring yesterday by taking out GCF. Finding the greatest common factor will always be your first thing to check for when factoring. These first few that we're going to do today probably aren't going to have one, but they are going to before the period's over, so we got to check for it. So, that being said, I already gave the way here. Is there a greatest common factor other than 1? No greatest common factor other than 1. Yesterday, when we had something that there was no GCF other than 1, we talked about grouping it. Can't group this because there's 3 terms. 3 terms doesn't split evenly into 2s like the ones yesterday. Yesterday they had 4 terms when we grouped them. We're going to use some grouping today. Eventually we'll make stuff have 4 terms, but we don't need 2 here. Alright, there's no GCF, there's only 3 terms, so our plan of attack now, we do A times C. Remember, standard form of a quadratic is ax squared plus bx plus c. So we take the product of A and C. What's my coefficient here in the A spot? 1 times 20. So I'm looking for the factors of 20 that add to B. Now that's easy schmeezy. You already know them. I'm going to write them all this first time to show you, but you don't have to do this every time. I could multiply 1 times 20 to get a positive 20. I can multiply negative 1 times negative 20 to get a positive 20. I can multiply 2 times 10, or negative 2 to negative 10. I can multiply 4 times 5, or negative 4 and negative 5. Those are all of my factors of positive 20, correct? I'm looking for the pair of those that adds to 9. Okay, 1 plus 20 is 21. That's not 9. Negative 1 and negative 20 is negative 21. That's not 9. 2 and 10 is 12. Not 9. Negative 2 and negative 10 is negative 12. Not 9. 4 and 5. Ding, ding, ding. We're in chicken dinner. That's a sum of 9, right?
Yeah.
So all we have to do now to factor this, since it's A squared, that means it's going to be A times A. I got a positive 4 and a positive 5. That's it. You've been doing that for a while now. Factoring does not go away in math. You got to keep it up, keep it up, keep it up. As long as our A is a 1, they're that easy. We'll get to them by the middle of the period today where A is not 1 and we got more work to do. A lot of those review sheets you had while I was gone last week were that stuff. Remember that? Alright, are you going to try another? I got B squared minus 7B plus 10. Alright, is there a GCF other than 1? Hello?
Yes.
What is it if there is?
1.
Other than 1, is there a GCF?
No.
No, Zane's correct. There's not anything other than 1. What's A times C? 10. Dustin's got it. What are the factors of 10 that add to negative 7?
Negative 2 and negative 5.
Got a kid. So we got B minus 2. Whoa, that was dumb. Don't do that. Times B minus 5. Okay, make sure you follow the signs on that. Negative 2 and negative 5 is positive 10. Negative 2 plus negative 5 is negative 7. Okay? One thing that I always remembered, when you've got a trinomial such as this, if your last sign's positive, that means your signs are the same, and they're the same as whatever the first sign is. So you can always do a check on that. If I needed to, if I wasn't sure, if I'm like, oh, that's too easy, how do I know if that's right? What would I do to check my work? And boy, just FOIL this and you'd be back to where you started. Factoring and multiplications run in a big circle. You do it and undo it, do it and undo it.
What does FOIL stand for?
First, outer, inner, last. Hey, Aaron. Doing all right today? I'm tired. My neck hurts. See if I can find something else to complain about in a minute, Dustin.
I'm sure everybody will can.
I got a crit. I don't know why. Hurts. Just trying to talk to somebody else.
You sleep
Sleep
wrong.
wrong.
That's what everybody says, but I didn't know. I mean, I sleep the same way I always do. I'm a tosser and turner.
Maybe you got into a weird position and slept like that for a while and then you turned it.
Try not to do that anymore. Hey, how about t squared plus 3t minus 5? That's a plus 3t they hooked together on accident. T squared plus 3t minus 5. Do I, hey fellas, do I have a GCF other than 1? Correct. Hayden is correct. There is not a GCF other than 1. Okay? So, what's my A times C? Negative 5. Alright. Factors negative 5. I mean, 5's prime, so you're just dealing with 1 and 5, so you can be negative 1 and 5 or 1 and negative 5. Correct?
Correct.
Which pair of those adds to 3?
None of them.
No, I'm right. This one would give me 4 if I added them.
Yeah.
This one would give me negative 4 if I added them. Doesn't give me 3. Okay, yesterday we had stuff that couldn't factor and we wrote out cannot factor. Today we're going to use the correct math term. So think about some little type math here. When something doesn't have any factors other than 1 in itself, it's called a blank number that starts with a P.
Prime.
Okay. That is prime. Can't factor, it's prime. I like it a lot. Feels like, sounding like the air finally kicked on. I've been burning up all day long. I knew I'd find something else to complain about. Try to be a positive person, but I'm just rolling off the complaints today. So, this morning on the way to school, I was like, man, it's been a long week. I'm going to play the Hump Day commercial video today. And then I realized it's not even Hump Day yet. I was like, dang, that was depressing. Can't even play the Hump Day video yet. Whew. Yep. Tomorrow I might be thinking it's Friday already. Alright, we good? Good over there, Michael?
Huh?
You good?
I'm splendid.
Good in the hood. Splendid.
I'm good in the hood.
How about if we added a second variable? P squared minus 5p cubed. Mind your p's and q's. That was an old timey saying. Plus 6q squared. Alright. Is there a GCF other than 1? No. No GCF other than 1.
No.
Normally, we got a 1p squared, so we know that's going to be a p times a p. Right? But it also ends in a q squared. So what do you think that's going to do to this thing?
Just a cube.
Boy, Mason. We'll end in a q times a q, right? Okay, now we're going to do it the same way. So that's the only difference that second variable got us since it's q squared. Got to have a q times q. Alright, what's my a times c? 6. Michael's on board. Factors of 6 that add to negative 5. Careful. Good. Negative 2 and negative 3. This morning they said negative 6 and 1. Negative 6 times 1 does not get me a positive 6, does it? Had to be the same sign, so Hayden is fantabulastic there. That's it.
Bam.
He sees it. He sees it.
Oh wait, it has me thinking though, like, you see how you did P, Q in one parenthesis and then P and Q in the other? Well, how could it do that if there's only one P?
What did you say?
Or never mind, there's one in front of it.
Good thinking though.
I have some of those.
Alright, now, all of those, listen, come on. All of the ones we've done so far, the A has been 1. It was a 1p squared or a 1t squared or whatever. Those are the easy ones. Those are the baby step ones you did in the 8th grade. Then after that, we had to do when the A is a 2 or a 3 or a 4. It gets a little bit more complicated. Okay? So let's jump in.
Alright. All right. We're sitting outside. Out there talking.
6k squared minus 19k plus 10. Do we have a greatest common factor other than 1? No, it's correct, Mason. 19 is prime, right? When you got a prime number in there, that's a pretty good indicator
That's you.
that you're not going to have anything. You're right, Michael. All right, so we don't have a GCF. I still am looking at A times C, but my A's not 1 this time. So 6 times 10 is 60. I need the factors of positive 60 that add to negative 19.
5 and -5 and -12.
Now that'd give me negative 17. You're close. She said -5, -12. She's in the ballpark. That's negative 17.
-15 and 4. -15 and -4.
How about that?
Oh, there you go.
There you go. Hey, attaboy. Alright, negative, hey, simmer. Negative 15 times -4 is a positive 60. Negative 15 plus -4 is a negative 19. Now, when my A is 1, I would just plug those in and I'd be done. But my A is not 1, so now we have to do this by grouping, which is what we did yesterday. So if this is the same as that, and it is, I'm going to take negative 19 out, substitute these dudes in, and that's going to give me the 4 terms, and then I can group them. Okay, so I got 6k squared minus 15k minus 4k plus 10. Question, does it matter which one of these I put first? And that's a trick question. Good, Chase. Sometimes it does.
Oh, okay.
Remember yesterday we had a scenario where we had to flip them?
Oh,
Sometimes this might not work, and I might have to flip them. Okay?
It just makes the equation bigger.
Yep.
When you're trying to make the equation bigger.
Because now I can split it into 2 little
Now you gotta
ones.
solve it.
Alright, so out of this first group that Baylor just found us, what's the GCF?
3K.
3K. That leaves me with 2K minus 5. Remember, whatever I take out of here, my goal is to also have a 2K minus 5.
Yep. 2.
Close.
-2.
Negative 2.
Negative.
Okay? So, we write our answer now. What we had twice times what we took out.
That's pretty easy.
It is. And you know what's even better is our test in here better or multiple choice. So if I gave you this thing and told you to factor it and you had no idea how to, you could go to choices and foil them, work backwards.
That's what I like doing on that.
Sometimes that takes you, waste your time on ACT, but this isn't ACT, so, you know.
Have you ever had someone not finish by the time the class is over?
Yeah. Some people are just not
Are you
speaking.
cool about that, or do you?
It depends on what it was and if I could tell if they were really trying or not. You know, sometimes people just get distracted and watch a movie. That I'm not cool with, but it just depends. We good in the hood?
Yes.
Yep. Smooth it up. Hey, I want you to try one. Great idea, thanks. 10x squared plus 17x plus 3. Try that one on your own, just like the one we just did. Get it?
Okay. All in my head.
Oh gosh, I'll go through these. 10x plus 17x plus 3. There you go. Put 2 times 2 equals
So it's
17.
the same stuff we did on that first before we were gone.
This problem might be a little bit harder than some.
Do we bring out a 1?
Yes.
Okay.
And it depends on what order you put your 15 and your 2 in. So which, did you put the 15 first?
I put the 15 with the
Okay.
10.
Okay, that's the way I'm gonna do it then, 'cause that's a.
Which one does the X go on? On the, or don't you have to, what, boy?
When you substitute your factors in, it goes on
You
both
gotta
of them.
split
Both
that
of them?
in half.
Uh-huh.
You gotta split
Oh, okay.
it. You must know your teacher.
Yeah, it was.
I'm pretty sure it's.
I know the last one.
Alright, what was A times C?
30.
Times C, it was 30.
What factors of 30 added to 17?
Could you do?
Now, go ahead, Ballard.
Oh, never mind. You got it.
Well, 15x and 2x is what I'm going to substitute in for the 17x. And this is a cool problem because it'll work either way. You can put the 15 first and it'll work, or you can put the 2 first and it'll work. You know, we talked about the order you write them in. It's a good teaching point for me to you to put the 15 first. So I'm going to do that. Then it would work either way on this one. Lots of times when I work these problems, I try to envision coming ahead, and I'm like, well, yeah, 15 goes with 10. They got something in common. But 2 doesn't have anything in common with 3. So I might flip that. That might be how I would do it on my own. But this teaches us something with the 1 that we got to remember, so I want to do it this way. All right, we got 4 now. 2 by 2. GCF of this group. 5. X. Good.
I always forget that.
10 divided by 5 is 2. X squared divided by X is X. 15X divided by 5 is 3. Whoa. That's what you already got there. Good. So what do I don't want to change this.
Why don't you
The
put
only thing I can take out is a 1. So now I got 2x plus 3 times 5x plus 1.
I just totally overthought that.
I see
What do 2 and 3 have in common, Mason?
Oh, never mind. I'm not.
Nothing other than 1, right?
Couldn't you do the same thing except the X on the outside over here could be a 2 and then the X inside would be 5 and
Okay.
then
Yeah, I would have to do what Baylor's describing. It would be if I switched the 2 and the 15. If I wrote that in the opposite order. So now
Oh, no,
here,
I wasn't talking about that.
well, okay,
I was talking about there'd be 10 on each side that would be split up, and then instead of that being a 2, that would be a 7.
instead of
Earlier confused me.
this being a 2, show me. I'm not with you.
Instead of, alright, see how this is 15 and this is 2?
Uh-huh.
This would be 10 and this would be 7. And then that'd be a 1.
But 10 times 7 doesn't give me the 30. It's got to,
Oh.
I got you now. Okay. Where are you at?
I didn't do it.
Okay, did you put the 2 first? Let me do that.
I just don't know two front numbers.
We will show you. 2x squared plus 2x plus 15x plus, what was the last one? 3?
Yeah.
That'll make you dizzy, won't it? Alright, so you took a 2x out of here? Okay. 10 divided by 2 is 5. X squared divided by x is x. What's 2x divided by 2x? No?
One.
Okay, did you do that? Get that? Okay, what's your GCF here?
3.
Uh-huh. So 15x divided by 3 and 3 divided by 3. Okay, did you get here? So you know what to do so far?
Well, I messed up on the 1.
But other than that, you know where we got. Okay, now to write your answer, you take what the parentheses you had twice and write that. And then you take the stuff that you took out, and you put that in a parentheses. Cool, cool.
I don't know.
Alright, alright, alright. Alright, let's look at, I got negative 2p squared minus 5p plus 12. That's 12 where my 2 and my 1 hooked together. Negative 2p squared, listen fellas, minus 5p plus 12. GCF other than 1? No, you're right. However, this is a case where I'm still going to factor something out.
Negative.
Very good, Kaylee. Anytime my A is negative, it makes my factor work harder. Because I can't, if I'm trying to make a parentheses with something times something, it's always positive, right? Because a negative times a negative is positive. So I want to take that negative out. So I can divide this whole thing, factor out a negative 1. Change that to a positive 2p squared, a positive 5p, and a negative 12. Now that makes this factor easier for me. Okay, so I'm doing my a times c in there. A times c in there would be negative 24, because 2 times negative 12, right? I need the factors of negative 24 that add to 5. If you don't know, just list them. It's not embarrassing to list them all, but anybody got them? Factors of negative 24 that add to positive 5? 8 and negative 3. Good. Now, I'm going to substitute those in for the 5. So here's my thought process. I know 8 and 2 have something in common, and I know 3 and 12 have something in common. So I'm going to put the 8 closer to the 2 and the 3 closer to the 12. Okay? Hang on to this negative. Don't lose that negative. We're going to come back and pick it up when the bus makes its second round. Alright, so just hang on to that. 2p squared plus 8p minus 3p minus 12. What's the GCF of the first group? Shh. Hey, pay attention. Thank you, Mason. 2p leaves me with p plus 4. What's the GCF of my second group that will also leave me with a p plus 4?
Negative 3.
Good, Kaylee. Negative 3 leaves me with p plus 4. Okay, so to write this, it doesn't matter which one of these you put first. I always put the one that I had twice first, just because I'm a creature of habit. And then make parentheses for what you took out. Now, bus is making its second loop now. Don't forget that negative that we took out. You got it, Mason?
So if you plug that into the calculator, what would you see?
I don't know. The calculator, when you plug a variable like that in, assigns some random value to the calculator, and it'll like say 7. It'll give you an answer. It doesn't do the factor. It's crazy. Crazy. Alright, we just got a couple more. Hang in there, hang in there, hang in there. Got this one, got what we need here? Alright, last two, the most thought-provoking kind. I got 2 times x plus 3 squared plus 5 times x plus 3 minus 12. Now this type of factoring problem, listen, shh, this is the least common. You don't see these very often. So as a result of that, we don't remember how to do them as well because we don't practice them as often. This is the same as the stuff that we've just done, but instead of just an x, we've got an x plus 3, right? That whole binomial is there instead of just an x. So what you're going to do to simplify this, you're going to take that binomial and you're going to just set that equal to some random variable. So I'm going to say t is equal to x plus 3. Okay, you pick whatever letter you want. Now I'm going to rewrite this thing with just one variable in there instead of a binomial to make it what we know how to do. So I'm going to have 2 instead of x plus 3. I'm using t plus 5t minus 12. Now we know how to do this, right? A times c, 2 times negative 12.
24.
I think we just had these factors, didn't we? Ones that add to 5 are...
8 and negative 3.
Uh-huh. So let's see, they're matched up good like that. Same stuff we just did. Okay, so we're grouping here. GCF of this group
2t,
leaves us with,
4t plus 4.
okay, GCF of the second group,
3.
negative 3. Good. Alright, so nothing's new. We got t plus 4 twice.
And then 2t minus 3.
Uh-huh. Now here's where we got to add some steps in. T is x plus 3.
So we got 4.
So I got to come back here to my simplified answer, and instead of a t, I've got to put an x plus 3. So this is going to be x plus 3 plus 4, which let's just stick with that one because we can clean that up. X plus 7, right? Okay, here, 2 times x plus 3
2x
What did we do with that other negative 3? Oh, no.
Yeah, where's that negative 3 come
right here.
Right there.
from? Oh.
You don't see those very often.
It's not very hard.
No.
You just gotta remember that.
Right.
Go back.
Yep.
Yeah.
Can we do one more? Yep. We got what we need on this one? Just want to show you in case it's a higher power than 2. 6r to the 4th. Oh my goodness. Minus 13r squared. Plus 5. Alright. All of them so far have started off with our a was the variable squared. Sometimes you'll see it to the 4th. 4th is the same as squared. If I had x squared, that's x times x, right? If I got x to the 4th, that's x squared times x squared. Okay? So we work at the same, but instead of just an x in our parentheses or an r in our parentheses, it's going to be an r squared and an r squared. Alright, so do we got GCF other than 1? No? I mean, 13 and 5 are prime, so no. So a times c is a positive 30. I need the factors of 30 that add to negative 13.
And then negative 3.
Close. Make them both negative, right? Uh-huh. Now, look at the numbers that I'm fixing to put that by. I probably want to flip my order, don't I?
Yeah.
Because I know that 10 would go good next to the 5. Good. So I'm going to write 6r to the 4th minus 3r squared minus 10r squared plus 5. It might work the other way. I don't know. I didn't do it that way yet. Chase.
Not supposed to be r squared. You wrote negative 3r squared minus 10r squared. It's supposed to be just r.
No?
Because you would add them together.
Oh, yeah.
Yeah. When you add them, the powers stay. Good thinking, though. Thanks for paying attention. All right, any other before we group it?
Solid group.
All right. What's my GCF for that first group?
3r.
R.
Not 2r squared.
3r.
3r squared. That's what you did, I know. That leaves you, here's where you were, it leaves you with,
2r.
what's 3r squared divided by 3r squared?
Minus 1.
Minus 1. All right, well, we need to take out the second one that would also leave us a 2r squared minus 1.
Negative 5.
Negative 5, because we need those signs to change. Negative 10 divided by negative 5, that's a positive 2r squared, and 5 divided by negative 5 is a negative 1. So, we got a 2r squared minus 1, and then a 3r squared minus 5. Remember when we started, I told you there's a way you can check your signs. Go back to your original problem. This plus sign tells me the signs of my binomial have to be the same. They got to be the same as the first sign. Minus, minus. It's just another little mental check you can do every now and again. Alright. Tomorrow's stuff is still factoring, but it goes to the special kinds of factoring, like difference of squares, difference of cubes, all that stuff. Okay? I like factoring. I think of it like you got a bicycle and you take it apart and put all the parts across the garage floor. That's what you do when you're factoring. You're taking them apart and spreading them out.
Good eye.
No exit question today.
Those are you weren't here.
Huh?
It wasn't like I know I got one.